Hello everyone. In last video we have seen that how we can select a most suitable structural formula, and for that the criteria for most suitable structural formula, it was number one, first thing, that we should have nmax, the maximum nmax value, node addition, or we can write down that node addition, it should be maximum. And there is one more criteria, the second criteria, the p value of last stage should be lesser. Now, as our problem is of two-stage problem, so this condition it is applied for greater than two stage. So this we are not going to use it this much. The first condition it is satisfied for us. So the second case it is for three stage or more than that. So as per our calculation in all criterias, we have the most suitable formula, that is 2 in bracket 1 and 3 in bracket 2. Now here our subsection A it is completed. Now we will proceed for section 2, like question B. Now that is which is asked for a ray diagram. So from here we will start with drawing of a ray diagram and speed chart. So what is ray diagram? Actually, ray diagram is also representation of structural formula only, and it shows you the transmission. So the ray diagram, it is a representation of structural formula, and next one, that it shows you transmission line. Now how to proceed with ray diagram? For ray diagram, first we will calculate all the speeds. Now we know that we have geometric ratio, that is phi is equal to 1.41, that is already mentioned in the numerical. Now from that again we have calculated z value, that is it is 6. Now means what, we are having total 6 speeds in a gearbox, and there is one more speed that is of motor, or it is also denoted as engine motor, and which is equal to 1500 rpm, that is 1500 rpm. Now we will denote it as engine motor, or nm. Now before starting with this, we will calculate all the speeds. So for calculating all the speeds, first we will get with first speed, that is n1. Now in our case n1 is 120 rpm. Now for calculating n2, as we are dealing with geometric progression ratio, so it should be n1 into phi. So n1 is 120 rpm and phi is 1.141. Now it is equal to 169 rpm. Now similarly for n3 we can write n1 into phi square. So instead of showing calculation, I'll directly write down the values, and n3 it becomes 239 rpm. The next n4 is equal to n1 into phi cube, which is equal to 336 rpm. Similarly n5, now n5 is n1 into phi raised to power 4, that is 474 rpm. And last one, it is n6, that is n1 into phi raised to power 5, which is equal to 669 rpm. So through these things we have calculated 6 speeds. Those are like this. So n1 is 120 rpm, n2 is 169, n3 is 239, n4 is 336, N5 it is 474, and last one N6 it is 669 rpm. Now here N6 is the last step, so we will write like this. So here Nz, which is equal to N6, which is equal to 669 rpm, and we have already discussed that Nm, we will write it as engine motor or just motor, which is equal to 1500 rpm, that is 1500 rpm, which is supplied to gearbox. Now here also we have one criteria for drawing a ray diagram. Now we will write down the criteria. Now criteria says that if we have engine motor, the speed of engine motor, it is greater than Nz, it's this value 669, and here it is Nem. Now this is the condition actually in our problem. So if engine motor is greater than Nz, then the vertical lines we need to draw, vertical lines will be n plus 2. Now n, it is number of stages plus 2, which is equal to 4, and horizontal lines, for horizontal lines we should have z, total speeds, plus 1. Now we know it is 6 plus 1, which is equal to 7. Now in our case we are going to follow this. But what if this criteria is not fulfilled? Means what? If Nem it is greater than, sorry, it is lesser than or equal to Nz, then these vertical lines, it should be n plus 2, that is similar one. Now here from this it will be 4, and horizontal lines, that will be equal to z only, that is 6 in our case. But in our cases this first condition is satisfied, so we will get with this, that we are going to draw 4 vertical lines and 7 horizontal lines for drawing or for completing a ray diagram. So we will start with that. Before that, we need to draw structural diagram first, or we need to refer structural diagram first. So I'll just draw it quickly, a structural diagram, so that it will be easier to compare. So in structural diagram we have 3 vertical lines and 6 horizontal. So this is 1 2 3 vertical lines, 2 3 4 5 and 6. So again here we have speed 1 2 3 4 5 6, and if we check for shaft, so we have 3 shafts, shaft number 1, shaft number 2, shaft number 3, and structural diagram is 2 in bracket 1 and 3 in bracket 2. Now we have already drawn structural diagram, so I am not going to repeat it, I'll directly draw it. So this is 1 2, so just join the lines again from this. So here we have completed our first thing, that is structural diagram. So from this structural diagram we are going to draw a ray diagram. So already we have determined that we are going to draw 7 horizontal lines and vertical lines which are equal to 4. So we will draw the same one. Now this is 1 2 3 4. So there are 4 vertical lines and 7 horizontal lines, 1 2 3 4 5 6 and 7. So we have total drawn 7 horizontal lines and 4 vertical lines. So we will name it, this is speed 1, or we will write down n1, this is n2, this is n3, this is n4, this is n5, this is n6, and the remaining part we will keep it later. Now this is shaft 1, this is shaft 2, this is shaft 3. Now what about this point? It is the motor shaft, or through this point we are going to get a direct speed from the motor. Now, as already we have described that ray diagram, it is a representation of structural formula, and it shows transmission between the last shaft and preceding shaft. This is most important thing, that it shows you transmission, between or of last shaft and preceding shaft. So now we will draw with the ray diagram. For ray diagram, you have to check for the lowest lines or lowest speed. Now in our case, if we check for the structural formula, the lowest speed is 1. So here we will fix with the first point. Then after that, the related point with it, it is 3 on shaft 3. Again, after that, we have relative point, that is 5. Now it is the last shaft, it is the speed of last shaft, and next is it is preceding shaft. Now for preceding shaft, it is shaft 2. Now the thing is, in our case, for preceding shaft, if we check with the diagram, so here we have line 3, point 3. But we are not going to deal with that. We are going to take the second point. This is second point. So at 4. So while drawing the ray diagram, you have to get with this point, the next preceding shaft. Again, this is just for this numerical. Why is that so? Because it satisfies our criteria that here the motor speed, it is greater than the last maximum speed, that is NEM, it is greater than NZ. That is why we are doing this. If we have different criteria, then we have to follow different one. So for this numerical, we are following this. Now here we are going to join these points. Now this is regarding for shaft 2 and 3. Again on shaft 2 we have the next preceding point is this. Now here it was N4. Now here we are getting N5. That is fine. After that, the next point on shaft 1, it is somewhere here at this point, but we are not going to deal with this. Now for that, we are going to directly get with the next point, that is N6, and we are going to join it. Now as the definition says, it is preceding shaft, the last shaft and preceding shaft. So we are going to get it this point, we are going to join it, and the last one, that from the motor shaft, we are going to get this speed. So if you check with the structural diagram and ray diagram, you will come to know that both are similar, the speeds are similar, but only the thing is that it is a relation between the last shaft and its respective preceding shaft. Now here we have selected N1, N3 and N5 as per our structural diagram, that those were the lowest speed. After that, we have added +1 in this ray diagram, means instead of third point we have taken fourth. Then after that we have taken fifth point, that is N5, and at the end we have selected N6, and from that N6 we have joined to the motor shaft. So this is the ray diagram which is asked for 5 marks. So you can write it that same pattern, that for shaft 1 and 2 it was 2 in bracket 1, and for shaft 3, sorry, for shaft 2 and 3 it is 3 in bracket 2. So here it completes our ray diagram. Now for speed chart, it is the similar diagram. We are going to draw everything similar, only we are going to complete the remaining lines of 0.5. Now how? Let us see. Now we are going to copy exact similar structure. So we know that it is 4 lines we have, 1, 2, 3 and 4, and we have total 7 lines. So 1, 2, 3, 4, 5, 6, and here we have 7. So total 7 lines. Now after that, here we are going to write its speed. So it is N1, here it is N2, N3, N4, N5, N6. Now here we have shaft 1, shaft 2, shaft 3, and this is machine shaft. Now after that, here if you check for the speeds, it is 2 in bracket 1 and 3 in bracket 2. Next, after that, we are going to copy the same one. We are going to first check for N1, then N3, then N5. Similarly, we are going to select point N4. We are going to join these points. After that, we are going to select N6. So here we have N6. So we'll join N6. It is next point. We have N5. Then we are going to connect the motor shaft. Then after this, we have 3 points remaining. For this particular point, we are going to join N6, N4 and N2. So we are joining those points and it is showing speeds at the respective points. So here whatever we have calculated initially, the speeds of shaft, that we can indicate over here. Now N1 it is 120 rpm. Now N2 it was 169. Then N3 it is 239. N4 it was 336. N5 it is 474. And N6 it was 669. Now everything is in rpm, revolutions per minute. So this shows you diagram, or this is our speed chart. Now all these things whatever we have seen, those are asked for 5 marks in exam. So here we have completed our section B. Now after that we'll see in the next video